So I wanted to go through in a little bit more detail the ConText software tool. ConText does a few things, but we are specifically interested in it for its ability to do topic modeling. Topic modeling can be done using programming approaches, but it is a pretty complex set of steps to do topic modeling using something like Python. And so ConText uses a kind of graphical interface to make that process a little bit simpler. So as you can see here, ConText is a tool that was created by members of the researchers at the iSchool at the University of Illinois. And ConText stands for Connections and Text. And it's essentially, as it says here, the tool supports the construction of network data from natural language text data, a process known as relation extraction, and also the joint analysis of text data and network data. And so, as it said, it does a lot, but I think specifically its most valuable contribution is simplifying the topic modeling process. And again, this is another example of an out-of-the-box tool that it kind of simplifies the process of doing some form of text analysis. And so what is topic modeling generally? And so topic modeling is generally a process that kind of works using some kind of AI-based or algorithmic approach to retrieve meaning from a set of texts. And so again, if you had thousands upon thousands of documents, it could be challenging to manually read all those documents to figure out what the topics are. And that's where topic modeling can come in handy. Using these AI-based / algorithmic approaches, we can get some insight into what a topic might be for a individual document, given its mixture of words and things like that. So yes, topic modeling is something that ConText can do. So if you wanted to download it, I'll share this link, but essentially you can go to context.ischool.illinois.edu and go to their download page, and there's a couple of different steps that you need to take. It is available to be used on both Windows and Macintosh computers. There are pretty good resources and step-by-step instructions on how to download the program and get it set up within their help resources and contact page with specific installations for Windows and Mac OS. And I guess in both cases there are some requirements. On Windows, it appears to require that it's a 64-bit installation of Windows 10. And if you would like to use ConText on Mac OS, you have to be of version 10.73 and above. But otherwise, I found the process relatively simple, and their website of installation relatively simple, and their website does a great job at explaining how to get it all set up on your individual machine. So let's take a quick look at ConText. And so again, ConText does a few different things, but for our purposes, we're interested in its topic modeling abilities. And so I gave a brief overview of what topic modeling is, but I really like this description also from the University of Illinois related to a little bit more of a background of what it is and the approach that ConText specifically uses. There's more than one approach to how topic modeling does, and topic modeling in ConText uses a approach called LDA, or latent Dirichlet allocation. And so as outlined here, and this is a post put together by Matt Pitchford at the University of Illinois, topic models work by identifying and grouping words that code together into topics. As written here, an LDA modeling makes two fundamental assumptions: that there are fixed numbers of patterns of word use. Groups of terms tend to be grouped together in documents, and so those groups of words together are essentially topics. And the second assumption it makes is that each document in a corpus exhibits these topics to a varying degree. So they give an example here of the topics of a particular, could be politics and film. So LDA will represent a certain book, such like J.E. Coombs and Sarah T. Coombs' Film Propaganda and American Politics and Analysis as Filmography, as partly about politics and partly about film based on the language that is within that document. As it says here, topic models don't have any actual semantic knowledge of the words and do not read the sentences. Instead, topics use a form of math. The token/words that tend to co-occur are statistically likely to be related to one another. However, that also means that the models that you can create using these approaches are susceptible to noise or falsely identifying patterns of co-occurrences if non-important but highly repeated terms are used. So essentially, the whole process of topic modeling, particularly when you use LDA, is a unsupervised AI-based approach to doing text analysis. And it doesn't, unlike our examples where we did supervised data, it does not require labeled text to get those topics from the documents, but it still relies upon human input or human labor to analyze the topics that come out. And this whole process will make a little bit more sense when we go through the example of ConText 2.0, where we do some actual topic modeling and take a little look at the results. And so I won't go into any further the background on how topic modeling works. It is a pretty complex process, but I think, at least from our perspective as non-specialists, we will see some of its advantages by using a tool like ConText. So here is the ConText interface. Essentially, if you want to do any form of text analysis, you would need to go within the menu options and go to text analysis, and then within summarization, you will see the topic modeling option. And then that will open this topic modeling tab here. And if you're ever confused about something related to ConText, this welcome screen is helpful. It gives you a little bit more information about what the software is itself, and also provides some steps as well. So this is essentially the documentation for this tool, and it's generally available when you launch the program. So all of these steps for doing topic modeling and some of the other functionality within the tool are available within this welcome menu and also through their help menu as well. So going back to topic modeling, essentially to do with ConText, there are 3 steps. The first step is selecting a space or a folder on your local machine where all of the documents that you want to do analysis on are housed. And so in this case, I've already done this step, but I have a directory on my computer that has a whole bunch of text files of historical New York Times obituaries. So if we open up that directory, you can just see there's I can't recall the number, but there's several hundred different obituaries from the years of different prominent individuals from the New York Times. And every single one of these is a text file. So for example, if we click on the one for Kristen Dior and we take a quick look at it, you can see that it's essentially the obituary and the text from the obituary. So we have a title, we have a date, and then we have the obituary itself. And I'd like to do topic modeling on all of these documents. And so all of these documents, essentially, I want to have a sense of, how I might be able to classify them. And so if I had 10,000 of these documents, it would be challenging to kind of get a topic for them manually. And this process will allow me, using ConText and its approach to LDA topic modeling will allow me to automate some of that. So key step is to have all of your documents that you want to do topic modeling on in one directory. And then you select it in step 1. And so then once that's done, you click next, and that will bring you to step 2. And there's a couple of different values you can play around with here. You can, basically my approach to doing this, I don't pretend to be an expert on it, but I will play around with these different numbers until I get something that is more meaningful in this 3rd step or this analysis step. And so I will start off maybe with 7, but I might see that when the topics that I've created are spit out, maybe it doesn't make a lot of sense. And so what I will do is I'll try it again and maybe try it with a smaller number of topics. So let's just stick with 7 for now and see how changing these numbers might impact how easy it is to analyze our different topics after it's done. So Topic modeling really is about playing around with the different parameters of the topic model so that you get something that you as a human can interpret. And we'll just start off with the default, and we'll probably have to do this several times before we get something that is more meaningful. There's also an option here to have a stop word list. I believe this is set up by default, but you could, for example, alter this text file if you found there was words that were occurring within your analysis that weren't as meaningful. So we saw this through some of our other examples. So the whole notion of stop words generally they are common words that don't add a lot to your analysis. And so, for example, quotation marks or small words like and or the don't really add much to what you're trying to figure out as far as a topic. And they can sometimes make the process a little bit slower or a little bit more challenging. So we will include a stop word list so that our topic modeling is a little bit more effective. And if you were so interested, if you found some words that are occurring that you want to remove from your analysis, you could alter this text file, or you could create one of your own. But otherwise, for this point, everything looks relatively well, so relatively good. So we'll go on to the third step. And that's just essentially setting an output directory for where you want this file to, the output of this file to live. So we will choose, and in my case, I will choose my desktop. I'm just doing it off the screen right now. So there you go. My desktop is where I would like all of the outputs for my topic modeling to go. And now at this point, you're essentially ready to run. So you click run here in the bottom right. And this will take a little bit of time. This is an AI-based process, and as we have learned, AI approaches can sometimes take quite some time, particularly ones using natural language processing. And so we are doing this, as it says here, on 380 different files. Every one of these is probably a 500 word or so obituary. So it will take time to crunch. And once, if you were in a case where you had 10,000 or 100,000 of these, you may find that it goes beyond the capabilities of your individual machine. And so if it's taking too long, just keep in mind that you may have to limit the amount of text that you try to do topic modeling on. So we'll just let this go for a minute, and when it's complete, we will look at our results. So when your topic modeling is complete, you should see a screen like this that essentially has a couple of different options, and it also, when it's complete, would have saved a directory in this case on my desktop of a lot of these results in a spreadsheet format as well. So if you want to take a quick look, though, you can look within the ConText interface itself. So if we click on Open Topic List, we can get a sense of the 7 different topics that it is identified with our settings as they are currently. And so you can see here that essentially these topics are represented by a list of words. And so from these lists of words, you are going to have to try to figure out something that kind of makes these words kind of be all in common, so essentially a topic. And so if we look at a couple of these, we see years, lifetime, world, work, York, year, times, American man. That doesn't seem to be quite as there isn't something clear there. But if we look at this second example, perhaps we get a little bit more information. So president, states, United States, Roosevelt, House, court, politicals. So this list of words could represent a politician topic or somebody who's involved in government in some form. If you look at this one here, topic 6, it might represent people who were kind of celebrities of some form or another. So again, you see music, band, jazz, baseball, piano. So again, it might, that collection of words may mean entertainers. And so essentially what you're going to have to do with this list of words is see if these words and these topics that it is provided for you can kind of be unified into one topic. So as you can see, there is a kind of human labor for you to participate, even though even though this is an AI-based process. That's one of the disadvantages of unsupervised learning approaches, is that it still relies upon human input to do the actual analysis of what is spit out by the AI models. And so this doesn't look too bad, but maybe we want to, if we want to get more specific information about, how a document is classified, we can go back to this topic modeling results tab here and look at open topic. And essentially here what you see is how much each document fits for the topics that have been specified. And so if we look at our example of, if we believe that maybe topic 5 is our politician related topics, we could organize this list. And so the higher the number, closer the number is to 1, the more the model believes that the document fits within that topic. So again, if we look back, topic 5 is the one that we think might be politicians. We can organize this list, this kind of spreadsheet view, by each one of these columns. So if we click on it twice, we can have it go from in descending order, and we can essentially see that for topic 5, for the most part that seems to make sense. Topic 5 is, in this case, it looks to be politicians from Eastern Bloc countries. If we were to look at topic 6, that might be a better example. If we organize by topic 6, which we think is the entertainment category, we can now see that our original approach might make sense. And so all of these, we can see here that the fit to topic of a lot of these individuals, all of these people are either musicians or athletes of some type. And so we have Lou Gehrig, who is a baseball player, Cy Young, another baseball player, Miles Davis, musician, and so on and so on. And so you can essentially use a combination of your topics, so your different terms that are you're given with by ConText and the LDA topic modeling, and compare that to the fit of what is given as well. And you could then, alter your parameters to try and see whether this list of topics makes more sense, and then you can cross-reference them against what you see within your results. So let's say we want to try some different parameters for what we did for our topic modeling. So an option in this to do that would be essentially clicking, when you're on the results screen, rerun the task with a new configuration. So perhaps we want to see what our results would be if we only had 5 topics. So that's the only thing we're going to change. Everything else will remain the same. We'll go next, and we will click on run. Maybe we'll change the directory just so we don't overwrite our previous results, and then we'll just click run. And again, this may take a little bit of time. So those it took about a minute or two with my machine to get the results. So let's see, now that we've changed our topic list to 5 from 7, let's see how our topics change. So we we can see here it's similar, but we have, again, it seems like our first topic is presidents. Our second, we don't seem to have as clearly, maybe this third example here would be celebrities. Maybe this fourth topic would be Cold War politicians from the Eastern Bloc. But we can look through the actual topic labels for all of our documents. So let's see, if we assume that this example, this third topic here, topic 3, is musicians and celebrities. Let's just take a look and organize it. And that one seems to still make sense. If you can see that the fit to topics is pretty good. If we look at the first one, which you maybe could think would be American politicians, topic 1, again, if we organize our results by fit, yeah, that seems to be pretty okay. You can see, it has different U.S. presidents and other governmental officials from the United States specifically. And maybe we could take a look here at our fourth topic, which is maybe Cold War politicians. Let's look at that one. So that was topic 4. And you could maybe see topic 4 doesn't seem to work quite as well, but generally it appears to be a combination of Eastern Bloc leaders with European leaders. So perhaps that might be your topic in that case. So you can look at, you can do kind of a sampling of which topics, which documents are being labeled by which topics to also infer a bit of a topic. So it worked relatively well. You'll have to basically do some type of approach like this to get a sense of what parameters for your topic model work best. All I can recommend is that play around with them a little bit and see what you get as far as words. And if those words have some form of, logical connection to one another, then try to look at some of the actual documents that fit well to those topics and see if they match up what you think those topics are. And then if they do, you can then, use something like this on a larger data set or on things that are documents that don't have, you might not be as clear about what the topic might be. So again, ConText, just another tool that can simplify one form of textual analysis. In this case, topic modeling, which is an AI-based approach that can automatically label the topic of a set of documents. But as you can see, even though it is a AI-based approach, the researcher or the worker still has a significant role in setting up and analyzing the results of this to get meaning from what the topic model has provided.